In similar triangles, corresponding angles have the same measure, and the ratios of the length, I have that underlined, ratios of the length of the corresponding sides are equal. That's a very big thing here. That is very big, very important. Ratios of the lengths. So we're going to use that fact to be able to answer questions related to missing sides of a triangle. If they're right triangles, it's easy, but when they are, anything else, similar triangles makes life a lot easier. So let's go with this one here. We have these two triangles. They are similar because the angle measurements are all equal to each other, and I'm doing examples with similar triangles, but the lengths of the angles, you can see by the little notch marks on each one, match up. So that's why they're saying they are equal to each other. So I'm going to find the ratio of two sides using x to be able to solve for it. So looking at these, I'm seeing, I got x here, so I know I got to use x and 10. So I'm just going to do these two because it just seems easiest. So the ratio of these two sides on these two triangles are equal to each other. So 10 over 24 is equal to x over 12. So just doing the ratio of these two exact same sides. Since they're equal to each other, I can solve for x. So I'm going to multiply the 12 over. So I'm going to have 12 times 10 over 24. And that's going to equal x. And I'm just going to do the arithmetic here. Just plug it in the calculator. So 12 times 10 over 24 is going to give me 5 inches. Since they're using inches as a unit of measure, I will stick with that as well. So x equals 5. So this is 5 inches. So if you do 10 over 24, you're going to get some decimal. And if you do 5 over 12, you're going to get the exact same decimal. That's how we can use the ratio of the lengths to solve for a missing side. It works every time. If you had done 10 over 18 and then x over 9 and worked it out, you have gotten the exact same answer. It's a matter of whichever you think is easiest or what you're given. Next, we got these two right triangles. So this little one here and this slightly bigger one here. So again, I'm going to do the ratio of their sides. So I'm going to do, let's see here. So x over 20 and 12 over 15. So that's just a way, if you kind of like break it off here and just flip it around, it would actually look more like this. So that's why I'm doing x over 20 and then 12 over 15. So x over 20 equals 12 over 15. Going to solve for x by multiplying the 20 over. So I'm going to do that. So I'll get x equals 12 over 15 times 20. And so again, when I do the arithmetic here, just throw it all in the calculator, I'm going to get 16 inches, because again, they use the unit measure of inches. 16. So if I do 16 over 20, I'm going to get a decimal, and if I do 12 over 15, I'll get the exact same decimal. That's why we can use the ratio of the lengths. Now what about something like this? So this one's a little bit more complicated, but we treat it no differently. We have this smaller right triangle, and then we have a bigger right triangle as well. So we're going to treat it the exact same way, ratio of the lengths. So let's see, I give myself some more room down here. So I'm going to do 4 over 5. So that's easy. This length over this length. 4 over 5. And it's going to be equal to this whole length over this. Now, it's different. There's a 5 here. That's easy. But over here, I have a 5 and an x. So if I add these two together, I would get this length. Don't know what x is. So I'm going to say it's just x plus 5. There we go. Now, to solve, this time I have x in the bottom, I'm going to multiply the x plus 5 over here and multiply the 5 over here just to clear the fraction. So I'm going to have 4x plus 5 equals 25. And let's see here, I can just distribute the 4. So 4x plus 20 equals 25. Subtract the 20 over. 4x equals 5, and then divide the 4 over, x equals 5/4. But since we're dealing with an actual length, I think a decimal will be better, so I'm going to call this 1.25, and again the unit measure is inches. So x here is 1.25 inches. And again, if you do the ratio of the sides, you're going to see that they are, again, to no surprise, equal. Now what about something like this? We have some man standing in the light of a light pole, casting a shadow that's 4 feet long, and he is 6 feet tall. He is 10 feet away from the pole, and we're going to find out the length of that light pole. So again, I don't have a tape measure to measure the length of this, but I can use the fact that his height is 6 feet, his shadow is 4 feet, and the shadow of the entire light from here to the end of his shadow is 14 feet. The base of the light to the shadow. So let's use that. I'm going to do similar triangles, so equal the ratio of their sides. So 6/4. And then I'm going to do, I don't know the top or the length of this whole thing to the top, so it's just going to have an x there. And then it's 10 feet plus 4 feet, so it's going to be 14 feet. Now I just solve. I'm going to multiply the 14 over. 14 times 6/4 is going to give me x. And then just do the arithmetic. X is going to equal, doing all that in a calculator, 21 feet. Again, use the unit measurement that's given to us. So this height of this light pole is 21 feet tall. So that's how using similar triangles can be done by just taking the ratio of two sides of the two triangles and setting them equal to each other.